Hello, friends. I am Satish Lele. I am a chemical engineer. I am working in the field of piping for the last 30 years. This video is part of my chemical process piping channel on YouTube. This video is about pipe stress analysis without expansion bellows. All pipes will be installed at ambient temperature. Pipes carrying hot fluids such as water or steam operate at higher temperatures. It follows that they expand, especially in length, with an increase from ambient to working temperatures. This will create stress upon certain areas within the distribution system, such as pipe joints, which, in the extreme, could fracture. Pipe work flexibility. The pipe work system must be sufficiently flexible to accommodate the movement of the components as they expand. In many cases, the flexibility of the pipe work system, due to the length of the pipe and number of vents and supports, means that no undue stresses are imposed. In other installations, however, it will be necessary to incorporate some means of achieving this required flexibility. An example on a typical steam system is the discharge of condensate from a steam mains drain trap into the condensate return line that runs along the steam line. Here, the difference between the expansions of the two pipe work systems must be taken into account. The steam main will be operating at a higher temperature than that of the condensate main, and the two connection points will move relative to each other during system warm-up. In practice, pipe work expansion and support can be classified into three areas as shown in figure. The fixed or anchor points A provide a down position from which expansion takes place. The sliding support points B allow for movement for expansion of the pipe work, while keeping the pipeline in alignment. The expansion device at point C is to accommodate the expansion and contraction of the pipe. Expansion fittings. The expansion fitting seen in figure is one method of accommodating expansion. These fittings are placed within a line, and are designed to accommodate the expansion, without the total length of the line changing. They are commonly called expansion bellows, due to the bellows construction of the expansion sleeve. Other expansion fittings can be made from the pipe work itself. This can be a cheaper way to solve the problem, but more space is needed to accommodate the pipe. Full loop. This is simply one complete run of the pipe and, on steam pipe work, should preferably be fitted in a horizontal rather than a vertical position to prevent condensate accumulating on the upstream side. The downstream side passes below the upstream side, and great care must be taken that it is not fitted the wrong way round, as condensate can accumulate in the bottom. When full loops are to be fitted in a confined space, care must be taken to specify that long-handed loops are not supplied. The full loop does not produce hot force in opposition to the expanding pipe work as in some other types, but with steam pressure inside the loop, there is a slight tendency to unwind, which puts an additional stress on the flanges. This design is used rarely today due to the space taken up by the pipe work, and proprietary expansion bellows are now more readily available. However, large steam users, such as power stations or establishments with large outside distribution systems, still tend to use full loop type expansion devices, as space is usually available and the cost is relatively lower. Horseshoe loop. When space is available, this type is sometimes used. It is best fitted horizontally so that the loop and the main are on the same plane. Pressure does not tend to blow the ends of the loop apart, but there is a very slight straightening out effect. This is due to the design that causes no misalignment of the flanges. If any of these arrangements are fitted with a loop vertically above the pipe, then a drain point must be provided on the upstream side as in earlier figure. Expansion loops. The expansion loop can be fabricated from lengths of straight pipes and elbows welded at the joints. An indication of the expansion of pipe that can be accommodated by these assemblies is shown in the earlier figure. It can be seen from figure that the depth of the loop should be twice the width. Sliding joint. These are sometimes used because they take up little room, but it is essential that the pipeline is rigidly anchored and guided in strict accordance with the manufacturer's instructions. Otherwise, steam pressure acting on the cross-sectional area of the fluid part of the joint tends to blow the joint apart in opposition to the forces produced by the expanding pipework. Misalignment will cause the sliding sleeve to bend, while regular maintenance of the gland packing may also be needed. Bellows may incorporate limit rods, which limit over-compression and over-extension of the element. These may have little function under normal operating conditions, as most simple bellows assemblies are able to withstand small lateral and angular movement. However, in the event of anchor failure, they behave as tight rods and contain the pressure thrust forces, preventing damage to the unit whilst reducing the possibility of further damage to piping, equipment and personnel. Where larger forces are expected, some form of additional mechanical reinforcement should be built into the device, such as hinged stay bars. Bellows may incorporate limit rods, which limit over-compression and over-extension of the element. These may have little function under normal operating conditions, as most simple bellows assemblies are able to withstand small lateral and angular movement. However, in the event of anchor failure, they behave as tight rods and contain the pressure thrust forces, preventing damage to the unit whilst reducing the possibility of further damage to piping, equipment and personnel. Where larger forces are expected, some form of additional mechanical reinforcement should be built into the device, such as hinged stay bars. There is invariably more than one way to accommodate the relative movement between two laterally displaced pipes, depending upon the relative positions of bellows, anchors, and guides. In terms of preference, axial displacement is better than angular, which in turn is better than lateral. Angular and lateral movement should be avoided wherever possible. Figure gives a rough indication of the effects of these movements, but, under all circumstances, it is highly recommended that expert advice is sought from the bellows manufacturer regarding any installation of expansion bellows. Expansion bellows. An expansion bellows has the advantage that it requires no packing, as does the sliding joint type, but it does have the same disadvantages as the sliding joint in that pressure inside tends to extend to fitting. Consequently, anchors and guides must be able to withstand this force. Pipe support spacing. The frequency of pipe supports will vary according to the bore of the pipe. The actual pipe material, like steel or copper, or rather the pipe, is horizontal or vertical. Some practical points worthy of consideration are as follows. Pipe supports should be provided at intervals not greater than shown in table, and run along those parts of buildings and structures where appropriate supports may be mounted. Where two or more pipes are supported on a common bracket, the spacing between the supports should be that for the smallest pipe. When an appreciable movement will occur, i.e. where straight pipes are greater than 15 meters in length, the supports should be of the rotor type. Vertical pipes should be adequately supported at the base to withstand the total weight of the vertical pipe and the fluid within it. Branches from vertical pipes must not be used as a means of support for the pipe, because this will place undue strain upon the T-joint. All pipe supports should be specifically designed to suit the outside diameter of the pipe concerned. The use of oversized pipe brackets is not good practice. Table can be used as a guide when calculating the distance between pipe supports for steel and proper pipe work. Thanks for learning. If you like this video, please give a like to my channel and subscribe it.